We'll be finding now some values of g at some different points a, b, c, d, and e for Earth. The values are given. G at surface of Earth is given, and we have taken 9.81 Newton per kg. Mass of the Earth we will be taking 6 to 10 power 24 kg, and radius of Earth is 6.4 to 10 power 6 meter, which is almost equal to 6,400 kilometer. I will not be erasing these questions, but I will be just finding those values. Let us see. First, he says point A is at a distance of 3,000 kilometer from center of Earth. I'll first locate the point. Suppose this is Earth, and this is the radius of Earth, which is 6,400 kilometers. This one. Now he says point A is at a distance of 3,000 kilometers. So this will be point A, and at a distance of 3,000 kilometers. Now distance from center of Earth is 3,000 kilometers. This is the distance from center of Earth, but it is inside Earth. So I will use the ratio method, and ratio method tells us that the surface of Earth I will take 6,400 kilometers. The value is 9.81 newtons per kg, and the 3,000 kilometers value will be x. This is kilometer, so I do not need to change those in meters. So x will be equal to 9.81 into 3,000 and divided by 6,400. You see, because this is inside Earth, so I use the ratio method. The distance is from the center, so it comes out to be 9.81 into 3,000 divided by 6,400, and it comes out to be 4.598, or I'll say 4.6 newtons per kg. This is point A. Now what about the point B? Point B, again, let's see, this was point A, simple. It's a distance from center was 3,000 kilometers. I use the ratio method. Ratio method is at a distance of 6,400 kilometers, the value of G is 9.81 Newton per kg. So at the value of 3,000 kilometers, what will be the value? Because inside the Earth, we will use the ratio method. And using the fact at the surface of the Earth, the value of G is 9.81 Newton per kg. But while using the ratio method, care must be taken. We will be taking always the distance from center of the Earth. Now next question will be clarifying that thing. Suppose he said the point B is inside the surface of the Earth. What is the point we first look at? Let us see. This is the radius of Earth is 6,400 kilometers from here. This Earth in kilometers, 6,400 kilometers. He says value of point B is 3,000 kilometers inside the Earth and from the surface of. So this is 3,000 kilometers. This one. Now if this is 3,000 kilometers, this point B, I will not take this distance for ratio method. I have to take the distance from center. So distance from center will be distance from center of Earth is here 6,400 minus 3,000. So it comes out to be 3,400 kilometers. Now I will use the ratio method. I will say it is 6,400 kilometer, value is 9.81. In the 3,400 kilometer, value will be x. So x will be 9.81 into 3,400 and divided by 6,400, and whatever the value comes out to be, it is the value of G at point B, 9.81 into 3,400 divided by 6,400, and I get a value of 5.21 newtons per kg. See the difference. Here I used directly this one, but here I first subtracted because I want to find the distance from center of the Earth. Then I can use the ratio method. But now, if the point is outside the Earth or on the surface of the Earth, then always we use the formula. That's simple. Now these three problems will be for the formula. He says point C is surface of Earth. He says show calculation. Means do not quote this value directly, just show the calculation. You know, G is equal to Gm upon R square, and the value of here now R is this one, which is the radius of Earth taken. So this will be 6.67 into 10 power minus 11, mass of Earth 6 into 10 power 24 upon this is 6.4 into 10 power 6 whole square, and value almost coming out to be 9.80 newtons per kg, or 9.8 newton per kg, up to two significant figure. It's not coming exactly 9.81, but because we have used inaccurate values whatever given. So it's almost 9.81 Newton per kg. So it comes out to be 9.8 Newton per kg at the surface of the earth. Now coming to the fourth point, the point D is at a distance of 8,000 kilometers from center of earth. I'll first locate that point where that point is located. He says point D is at a distance of 8,000 kilometers from surface, from center of earth. So this 8,000 kilometers is actually outside the earth. Now here it was not said it was 3,000 kilometers, so it was understood it is inside. Although he has not said inside earth or outside earth, but we have to determine whether it will be inside earth or outside earth. So this 8,000 kilometers, I've used directly this formula, G is equal to Gm upon R square. So G is 6.67 10 power minus 11. Mass of earth is 6 into 10 power 24. This is the distance directly from center, so it's all directly. So 8,000, I will change into meters, 8,000 into 10 power 3 whole square. So this is coming out to be 6.67 exponential minus 11 into 6 exponential 24 divided by 8,000 exponential 3 square. So it is coming out to be 6.25 newtons per kg. Now next point is very important, point E. And usually examiners test for this point. They have just given the point E is at a distance of 8,000 kilometers from surface of earth. Now I will locate where is the surface of the earth located at this where point E is located, because he has said, suppose this is earth, this is radius, and he has given point E 8,000 kilometers from surface of earth. So R becomes now 8,000 and plus 6,400 kilometers. So this is the 14,400 kilometers, or it is 14,400 into 10 power 3 meters. I'll be using, since G is equal to Gm upon R square. So I'll use 6.67 10 power minus 11, 6 into 10 power 24, and this is 14400 into 10 power 3 whole square. And I'll see what the calculation is coming out to be. 6.67 exponential minus 11 into 6 exponential 24 divided by it is 6.67 exponential minus 11 into 6 exponential 24 divided by 14,400 and exponential 3 whole square. It coming out to be 1.93 newtons per kg. So for all these cases, I'll again revise. When point is inside the surface of earth, use the ratio method, but distance should be from center of earth, and use the fact that the 6,400 kilometer, the value of G is 9.81 Newton per kg. But at the surface of the earth or outside the surface of the earth, always use the formula G is equal to Gm upon R square. But R must be from the center of the earth. If the distance is given from surface of the earth, then always add the radius of earth and then calculate. This is usually the examiners usually test here when they give the point which is outside the surface of the earth, and they give the distance from surface of. So this question is very much important.